All right, here we are in part one of our lecture video series from Wednesday, March 1st, where we talk about covalent bonds, which is our second type of chemical bond that can be formed between atoms. So recall in ionic bonds, we're looking at the bonding between a metal and a nonmetal. Specifically, we're looking at the bonding that happens between some metal cation and some nonmetal anion, where that cation and anion are ions as a result of either donating or accepting electrons from one another, which fulfills the octet on each atom, leaving behind ions that have some positive and negative charge, which are then attracted to one another, causing a strong association that we call a bond. So ionic bonds are only true for metal and nonmetal species, or if we're looking at polyatomics, anything with charge. Now, while most of the periodic table encompasses metals, you can imagine that if we were to be left with only ionic bonding, that we would be neglecting the different types of bonds that we see existing between nonmetals. So most fundamentally, a covalent bond is a bond that exists between two or more non-metallic elements. And as you might be able to glean from the word covalent, it involves how these atoms associate using their valence electrons. Now, in the case of ionic bonding, the valence electrons were donated or accepted. That's what allowed us to become a cation and an anion, respectively. So co now means together, like if you're going to co-parent or coordinate or cooperate. And valence, this is referring to our valence electrons. So valence electrons together, what does that mean? This means that when we look at how two nonmetal elements bond to one another, they do so according by sharing their valence electrons. Now, how would this work? Reminder, the reason why any atom does anything, meaning why it reacts or why it bonds to form a compound, is it tries to achieve the inherent stability of the octet rule or the duet rule, meaning we either want 8 electrons in our valence orbitals, or in the case of hydrogen and helium, 2 electrons in the valence orbitals. Because the valence orbital for hydrogen and helium is just that 1s orbital, can only hold a maximum of 2. So nonmetals can achieve octet or duet by sharing valence electrons with one another. So for example, we might look at a compound like water. So let's look at the oxygen atom's electron configuration. So this is 1s2, 2s2, 2p4. So this is me using a periodic table to get this electron configuration. And then each hydrogen atom is, of course, 1s1. And if I were to identify the valence electrons in each of these atoms, it would be the highest or last filled orbitals. So in the case of our p block, that is our last filled s and our last filled p. In the case of our s block, it is the last filled s. So looking at the valence configuration for oxygen, we see that oxygen only has 6 valence electrons. This is why it tends to form that -2 cation or anion so readily. It takes in 6 electrons, then it fills that octet. But we're not talking about becoming ions here. When we're talking about covalent compounds and covalent bonds, we're discussing these valence electrons being shared. So each hydrogen has one valence electron. And notice if you were to sum all these up, their total is 8 electrons, meaning that somehow this oxygen can share electrons with hydrogen to achieve octet. And in doing the sharing, these hydrogens would each fulfill their duet. So I'm going to show you a kind of just example Lewis dot structure, even though I'm not going to tell you how I got here yet. But this will give you an idea of where we're heading when it comes to the idea of covalent bonding. So what I'm going to do is I'm going to draw my oxygen atom, and I'm going to represent its 6 valence electrons as dots that surround the oxygen element symbol. So I've got 6, and I do want to be mindful of Hund's rules, so I'm going to kind of place electrons as far away from one another as I can. So I've got 1, 2, 3, 4, and then 5, 6. And then I've got each of my hydrogen atoms with 1 valence electron. And you'll notice if I were to take the 1s electron on the hydrogen atoms and share with these unspin paired electrons on the oxygen, we might see something like this. So I'm going to represent the hydrogen valence electrons in orange now, just so that we're really clear. So I would have oxygen and each of my hydrogens in this sharing of valence electrons, where if I were to count the valence electrons on my hydrogen on the left, we would see that that's 2 valence electrons. Hydrogen on the right, 2 valence electrons, so my hydrogen atoms have fulfilled their duet. And looking at the oxygen atom, that is 8 electrons. So by forming these shared valence electrons, we have created a covalent bond between each of our hydrogens and the oxygen atom. So in our next video, we are going to look at Lewis dot structures a little bit more in detail. So I'm just going to kind of go over not like the rules for how to draw them, but some things that you'll see pop up, like we're going to use dots to represent electrons, what a line is, some language that you'll see. And then from there, we'll start actually building these Lewis dot structures for various different compounds.